Hey guys, say you are given the numbers from 1 to 10 and your job is to place a plus or a minus sign before each of them such that the overall sum should be as close to 0 as possible but not negative. So it can be 0, it can be 1, any positive number but not negative. You can pause and think for a second. So the problem originates from the website Erdős, which is a website by IIT Roorkee. And there are a lot of problems here which anyone can solve, just a simple login is required. And today we'll be solving the first question from this website. It is a very easy one as you can see it is solved by around 3000 people, which is a lot for the website. So let's start by reading the question. Let there be a set of n natural numbers 1 to n, and we are allowed to insert a plus sign or a minus sign in front of each number and add the numbers. So our aim is to find a minimum non-negative value which is represented by d of n for the set 1 to n. So our final value which we have to output there is the value of d of 1 plus d of 2 plus so on till d of this large number. So it is simpler to break this down and find the value of the function capital D of n for a general value of n. So let's try it out. Let's try a simple trivial cases first. Capital D of 1 is the smallest uh, this is the smallest number in the domain of the function, and since we have to place a plus sign or a minus sign before 1, we can't place a minus sign as the sum would be negative, so the minimum value of the sum here is 1 itself. Let's try for the value 2. We have the numbers 1 and 2. If we place a minus sign before 2, then the sum would be negative irrespective of the sign in front of 1. So the sign here has to be a plus, and to minimize the sum we need to place a minus sign here. You can check the other combinations as well by brute force, but you'll quickly figure it out that this is the minimum value for d of 2. Let me write down the values in front of them. So for 3 we have the numbers 1, 2 and 3. If you see, the sum of 1 and 2 is 3 in fact, and if we add these and put a minus before 3, the sum collapses to 0. And since 0 is the minimum value in the range of the function which is required, so the value of d of 3 has to be 0. 4 is a very interesting case as well. So we have the numbers 1, 2, 3, 4. If we see, if we have a sign plus here, minus here, minus here, plus here. So 4 plus 1, 5, minus 2, minus 3, again minus 5, where the sum comes down to 0. So here again the value is 0. So let's try for a general value of n here. We can keep going like this. Let's try 5 before the general value. We have the numbers 1, 2, 3, 4, 5. So one thing we need to observe here, since the maximum sum which is obtainable here is 5, this is 10, 15. So the maximum sum is 15, and if so this is the maximum sum obtainable. If I change the sign in front of any of these, so the result 15 would be subtracted by an even number, which is 4 twice as as since the 4 was having a plus sign before it and now it has a minus sign, so the sum has subtracted by 8. So we can observe, even if I subtract an odd, even if I put a negative sign in front of an odd integer, the sum still goes down by an even integer. So the minimum sum here has to be an odd number, and hence it can't be 0. So let's try to figure out what the minimum number obtainable here is. So we know we can't obtain 0 here. Let's try the sum 1. If we have these numbers, so the sum is 15. If we subtract 14 from it somehow, then the sum would be 0. So for 14 we can put a minus sign before 3 and 4, and the sum comes down to 1. Let's try for 6. So if we do the same thing here, for 6 the actual sum, total sum, maximum sum is 21. So again this is the same case as for the uh, 5 part. So here again the minimum sum possible can't be 0 as it is an odd number. So let's try for 1. If we put a plus sign before this, a minus sign here, minus here, plus here. So these four cancel out each other. So we are left with 1 and 2. So this doesn't matter to us as the sum is 0. And from 1 and 2 we can get a sum of 1. So this is an arrangement which can give us the sum 1, and the value of d of 6 has to be 1. So let's try for a generalized n. So the ending numbers would be something like this: n minus 4, n minus 3, minus 2, n minus 1, m. So we can observe that these four cancel each other, as if we put a plus sign before this, minus sign before this, minus sign before this, and a plus sign before this, we get 2n plus 3 as the positive and minus 2n minus 3 as the negative. So this whole thing becomes 0. So we can observe that if we pair these into groups of 4, we are left with a few numbers at the front. So this is a good hint to classify these into 4 kinds. So d of 4k, d of 4k plus 1, d of 4k plus 2, d of 4k plus 3. So these are the only 4 types of numbers we will be dealing with. Any number can be represented as 4k, 4k plus 1, or 4k plus 2, or 4k plus 3. So the number 1 falls in the 4k plus 1 category, where k is an integer. Yeah, so for 4k, we can see that say 1, 2, 3, 4, 5, 6, 7, 8. So we can group these first 4, and if it were any number, 4k minus 3, 4k minus 2, 4k minus 1, and 4k. So the last four would be paired, these four would be paired, and everything in between would be paired. So the answer for this would be 0, as there are cancellations in these groups of four. For 4k plus 1, the maximum sum possible would be, let's do a bit of graph here. So for 1 plus 2 plus 3 dot 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 till n, the sum is n times n plus 1 by 2. So for 4k plus 1, the sum would be 4k plus 1, 4k plus 1 plus 1 by 2. So this becomes 2, and if we divide this by 2, we get 2k plus 1. 4k would be an even integer, as k is an integer, and multiplying anything with any integer with an even number gives an even number. So 4k is an even number, 2k is an even number. 2k plus 1 odd, 4k plus 1 odd. And odd times odd, we get an odd number. So here the overall sum is an odd number. So we can't get a 0 here using the same logic which we applied above. So the minimum sum which we can aim for is a 1. So let's try to get a 1. 6, 7, 8, 9. So since 9 can be represented as 4k plus 1, let's pair these 4, these 4. And we can see if we assign the signs this way, there are cancellations. So this group cancels out, this group cancels out, and we are left with 1. So the minimum value here we can get is 1, which we have also proved using this. So using the same logic for 4k plus 2, let's see what the maximum sum is. 4k plus 2, 4k plus 3 by 2. So here dividing this term by 2, we get a 2k plus 1 times 4k plus 3. So here again we can observe that this is an even plus an odd number is an odd number, and this is again multiplied with an odd number. So the sum here can't be 0 in any case, and the minimum sum can be 1. So let's try that out. So if we group these four, we would be left with 1 and 2. So putting a minus sign before 1, a plus sign before 2, we get the minimum sum to be 1 again. And since we have proved this is the minimum sum possible, this is the answer for D of 4k plus 2 type of numbers. And if anyone is confused that there would be numbers after this, these would be, so if we ignore these two numbers, there are 4k numbers here. So these 4k would cancel with each other, and we'll be only left with these two to deal with. So this is just a simplifying step to tackle the problem in a simpler way. And this applies to all these four cases. So here again, let's try the maximum sum. So here if we cancel this term by 2, we get a 2k plus 2. Since 2k is an even number, a 2 is an even number, adding these two we get an even number. And even number multiplied with any integer is an even number. So we know that this sum is an even number. unlike the previous two ones. So here we do have a chance of getting a 0. But will we be able to do that is a different question. So let's try it out. And since these are of the form 4k, 4k plus 1, 4k plus 2, and 4k plus 3. So these are of this form. So we know that we can group these in groups of 4 starting from the end, and we'll be left with 1 2 3 at the start. So these would cancel out, these would cancel out, and for any number of the form 4k plus 3, there would be numbers in front of this which would all cancel out. So we are left, ultimately we'll be left with 1 2 and 3. So 1 2 3 was a case we dealt with earlier, and we can see if we add 1 and 2 and subtract 3 from it, we get a 0. So here there is a way to get a 0. So we know the answer for these four forms of number. But the ultimate answer we are looking for is d of 1 plus d of 2, so on till d of 192.168.12112. So let's try to bring it in the form which we are trying to deal with. D of 1 plus d of 2 plus d of 3 plus d of 4. So here after that the sum would be 5, 6, 7, 8. So we know 1 is of the form 4k plus 1, 2 is of the form 4k plus 2, and so on. So for this group, d of 1 plus 2, d of 1 plus d of 2 plus d of 3 plus d of 4, the answer is 2, since we are adding 0 plus 1 plus 1 plus 0. Again, for d of 5 plus d of 6 plus d of 7 plus d of 8, these 4 are also of these forms. So this is repeating, and this is very useful to calculate the final result. So here also we'll get a 2. We can see from the last two digits of this number, this is actually divisible by 4. So for every pairing of 4, we get an answer 2. And we have to sum it all the way through till this number. So uh, if we divide this in 4, so we get so there would be 4 across, and downwards there would be 192.168.12112 by 4. So these many times we'll have to there would be these many groups of 4. So doing that on a simple calculator, we get, so these many groups would be there, and for each group the sum comes out to 2. So if we multiply that by 2, this should be our final answer. So let's try it out on the Erdős website. I'll remove the commas. It is not an acceptable answer for this website. and let's see if this is correct. Yes, we got the correct solution. So yeah, this is how we can solve this difficult, scary looking question in a simple way. So yeah guys, that's it for today. Thank you for watching the video. If you like solving difficult math problems, consider subscribing and following my socials. The link is in the description. I will be coming with more problems like this. And for the site, the first few problems are actually quite easy, but later on you'll see me struggling with the problems. I have also attached a link to my GitHub repo where you can find the solutions of all the problems I've solved. And you can also find my other projects which I've done there. These are obviously completely free. So that's it guys. This was the first video of the series solving Erdős. See you soon.